And I'm live. That is pretty cool. Today is 18th of April 2026, Saturday, and cool, the background just changed. Cool. Let's just begin. We have Docker. We know how to configure Docker or how to make images using Docker and run the project using Docker. We also know Terraform. Now we can use Terraform to start an AWS instance somewhere on the cloud. And yep. Wait. Yep. So yep, we now have out in DevOps. A few things are needed. One is how to run your code, how to run the code. That is done by Docker. We have Docker setup, so pretty cool. And then we need make the environment to run the code or get the computer to run code. For this, we have Terraform. Let's go. Okay. Cool. So we have these things. And now the third and final thing, hopefully the final thing, is keep updating the code. Keep updating the code. For this, we need CI/CD. Cool. And among these things, everything is done except CI/CD pipeline. Cool. This is done. This is also done. We just need to do this CI/CD, and that would be it for today. Or not for today, that would be like actually it. That would be it. Cool. So I guess what we will do is whenever we make a commit onto GitHub. So step number 1 is whenever a commit is made, we will define some steps, like some stuff that should happen whenever a commit is made. Whenever this thing happens, whenever a commit is made, we have some steps that should run. Step number 1, update the image on Docker Hub. Update the image on Docker Hub. Pull the latest image on remote machine. Okay. Update the image on Docker Hub. Pull the latest image on the remote machine, and then restart. Docker container on the remote machine. Cool. This is what we need to do whenever a commit is made. Cool. Which just means we need to set up CI/CD. Hello, where did you start Docker and stuff? Hello, from DMK. Docker is from boot.dev. You can go here. Boot.dev. They have a DevOps engineering path, and they like teach a lot of things. Docker is one of them. I only did Docker from here. Learn AWS. I now have a better understanding of why there is a full course on AWS, because AWS is very messy. Yep, there are VPC EC2 instances. Okay, I still don't know what they were. Shit. Wait, the color changed. Something happened. Something is wrong with this. I guess something is wrong. Okay. Yep. So you can learn about Docker from boot.dev. It is pretty cool. That is what I used. Good. So whenever a commit is made, we need to do some things. .github workflows deploy.yaml. The name of this thing is deploy. And whenever, or let's delete this thing. Shit. Wait, is there any other change? Yes, shit. Okay, we changed the file, that is the only thing. Okay. We deleted the file. Deploy.yaml, this file should run. Now, missing on. Okay. On push branches, that is going to be a list. Yep. Whenever there is a push on the main branch, jobs, run a bunch of jobs. Dispatch workflow, jobs. Job number 1 would be deploy. It runs on Ubuntu latest. Get the latest Ubuntu machine and do the following things. What are the following things? Okay. First of all, we need to push the latest image onto Docker Hub, which means we need to create the latest image. For create a new image. So how do we create a new image? There are things. Okay. Workflows, boilerplate. On push pull on a push request to this jobs, name of a job, where the job runs, steps. Okay, then we define steps. Steps is a list of steps, as you can see, and each step has a name and uses. Okay, sure. We can define GitHub actions here. So this GitHub action does checkout and GitHub actions. Hello, do you play game Minecraft? Sometimes, or it is better to watch someone else play Minecraft, like Technoblade, but he does not play Minecraft any longer, so no. GitLab CI. I kind of want to build intermediate level understanding on Docker and CI/CD for a possible job interview. How much time would it take? Maybe also add GitLab CI/CD. Okay, I guess a day or two if you go, because that boot.dev is a pretty cool course. 2 or 3 days. 3 days. Yeah, 3 days would be cool at max. And also, even if it takes longer, then it is fine. What is your aim? My aim is like get better at not competitive programming, but get better at programming itself and start earning, get a job. Like for now, that is the aim. And there are also strategic aims, like longer term aims. Actions. GitHub actions are like steps which run automatically, or like predefined steps. GitHub actions are like calling functions which are defined by GitHub itself. Okay, what all things are you learning together now? Right now it is just DevOps. Yeah, right now it is just DevOps. Main stack you work on TypeScript with front end and React. I mean, I've built one major project, nothing much. This chess project, this is a major project, and this uses TypeScript. The front end is written in React, and the back end is written in a library called Elysia. And there is also a TUI app for the same thing, which is written in Go. So yeah, that is it. Understanding GitHub Actions. Claude. Okay. It's very cool that we can ask Claude very specific questions and get answers to those questions. GitHub Actions, like functions which have been defined by GitHub and can be used by anyone who is setting up their CI/CD pipeline. And I do not know why they use the word pipeline. Yes, that is essentially the right mental model. Let's sharpen it. Okay, GitHub Actions, the platform. GitHub Actions. GitHub Actions is the platform. Lets you define CI/CD workflows in YAML. Within those workflows, you use actions, and these come in a few flavors. Okay, GitHub Actions is a platform which lets you define CI/CD workflows in YAML files. Okay, so when we are writing here jobs and things to happen, I guess there is also a name thing. Yep, name. Deploy latest version. This service is handled by GitHub Actions. Hey, got you. I will add you on my GitHub. Yes, I'm in college, and hello, Rahul Bhai. Official GitHub Actions by GitHub. Okay, GitHub provides actions. These things are called actions, which we can do when we are defining our thing, our workflow here. GitHub itself publishes and maintains a set of actions under the actions namespace. Okay, these are check out to clone your repository into the runner. Runner is the virtual machine which has been started by GitHub to run our workflow there. Actions setup node installs a specific node version. Okay, pretty cool. We don't need any of this. We just need Docker installed. Actions upload artifact, saves build artifacts, community third-party plugins, Docker push action. Yes, okay. Your own custom actions. Okay, that is pretty cool. .github/actions or publish them publicly. Okay, and then how do you call them? Like this. The v4 at the end pins it to a specific tag commit, which is important for security and reproducibility. The key analog your function mental model. Okay, that is pretty cool. Actions are predefined function like things which can be which are maintained by GitHub, maintained by third party, and these can also be written locally. Okay. Then how do I, just like exploration now, how do I write my own action which prints hello world, like, and nothing else? Okay, it is pretty straightforward. No Docker and anything is needed inside GitHub. Okay, inside actions, hello world, actions, action.yaml file, and inside action.yaml, name hello world description runs using composite. Composite is something steps and is run this and use the shell bash using composite. What is composite? And see inside ci.yaml uses actions checkout, and then this from the root, go there, action, hello world. Inside hello world, we have action.yaml. This action.yaml file will run. Adding inputs. We want to add inputs. Okay, we can define inputs. Describe who to greet. Required is not necessary to require, to be required, and then we can use it here. Inputs dot name. Okay, and like this. Okay. Now one more question is, we are just printing hello world, so why is Claude checking out this thing here? Simply printing hello world. Then why are you doing checkout? Why are you doing this expensive operation when this is not required? You are right question. For a local action, one defined inside your own repo, the runner. Okay, makes sense. We have to first get the actions and then run them. Cool. That makes sense. That is why we have to check out. Cool. Okay. So for these things, creating a new image, we have to do checkout. Where can we see actions like reference, workflows and actions, variables, actions, action, documentation. How do we see like custom actions? We can make custom actions. Actions provided by GitHub. Shade, where do we get a list of all the actions that GitHub gives us? Runners. Where can I see a list of actions that GitHub provides? And also, where does GitHub provide them? Marketplace. For official ones maintained by GitHub itself, go to actions. Okay. Some commonly used actions. Yes. Checkout. Shade. Okay. Checkout. And this thing defines what happens in checkout. And currently the version is 6. That is crazy. What is new? Improved credentials. Updated the 24 node. Cool. Okay. So first of all, we will copy our latest code with an action from GitHub whose name is checkout and version is 4. Okay. In steps. This has to be listed. Okay. Name is checkout, and then users actions checkout. Why version 2? We will use version 6. Totally this version. So first, this thing will get our latest code. Now we need to run. We need Docker. Ubuntu. We need Docker on Ubuntu latest. Shit, Docker is already installed. Okay, that is crazy. Docker is already installed. Okay, so we have Docker. Then let's write a action name which makes we have three things which we need to make. Create new image, but for what? We have we have the backend whose image we need to create, the front end, and the UI which is written in Go. Cool. These are the three images that we need to create. Cool. Docker build. Cool. So, and these images have to be production images. Workflows here, and I guess we should change the name of this thing to CD, which sounds more professional. cd.yaml. Hey, this is read only. Docker file, here we have defined how to make the images. We need to make the backend image. And is there, and I do not think that there is a difference. Yep, there is no difference in backend image for production and for development. There is a difference. Backend in development, backend will communicate to the local Postgres server, but in actual production, backend will communicate to the actual backend server. Okay, so that means in the backend, which means apps, backend, database is making connection. Yes, database is getting this thing from here, database dot URL, database underscore URL, and we are giving it this thing when we are running, when we run the image. So for actually building the image, we don't need to give this. Yep, we have to provide this as the environment variable when we run the image. So there is no difference between backend. There is no difference between backend production and production image and development image. Okay. I guess the fan is a bit too loud. Yep, let me turn it down a little bit. Pretty cool. Yep, I was not able to hear myself. Cool. Okay, so for backend, we don't really need to do anything. For backend, we can just say name build backend image uses this. Wait, shit, this uses, no, this does not uses this. Run, yes. And here we have to provide the command, which would be docker build target backend from the root. Yes, docker build docker tag. What is this? Docker push docker hub username. docker push github action. Why is this lagging? GPU, so much of GPU is being used. Brave is using, there are node processes running somehow, like random node processes. There is bun running somehow. Why is bun running somewhere? Bun is running. Doc. No. Log into Docker. Uses. Okay. Login with this and this. Okay. Build and push. GitHub CR. Container registry. Registry specific configurations. Okay. Standard workflow example, what we do is we check out, okay, we get the latest code, set up Docker buildx, but we are not using Docker buildx. We are not using Docker buildx. No, we are not using Docker buildx. Log into Docker Hub. Okay, to log in and build and push. Okay, this both the things, build and push, happen in this single actions. Build and push. Push true. Tag this Docker username slash my app latest. Okay, and we will change my app with backend, with the name backend. Makes sense. Lord, let's see how to build and push Docker image from GitHub workflow. Backend. This command will build the image, but we will use GitHub actions since they are available. Docker Hub token is needed and Docker Hub username is needed, and we can use this whenever a change on these things. Push and pull is the name of the job. Runs on Ubuntu latest step. Get the latest code. Log into Docker using this Docker login action. Okay, this is maintained by Docker. Cool. And then set up Docker buildx. Context. Okay, shit, this is like YAML. Push is true. Yeah, we will just put this equal to true. And tags. Okay, we'll put the tag. Key things. Why do we need Docker buildx? My bad. Why do we need Docker buildx when to latest comes with Docker? We can just build normally and then push since we are already logged in. You don't need Docker buildx for simple single platform build. Buildx is only worth adding when you need one of these multi-platform builds like Linux running on AMD 64 and ARM 64. The main reason it exists, but we are running on Linux on AMD 64, x86 64. The AWS server is x86 64, so we are not making this for multiple things. Docker action, layer caching. Wait, but the normal standard of instances on AWS is x86 64 So why do we need, so why would we need to deploy multi-platform builds if we want our code to be available to other developers, normal developers who might be using any platform? You wouldn't in that case if your target is standard AWS instance. Okay, makes sense. We are all x86 64, so a single platform build image is all you need, which is exactly what Ubuntu latest builds by default anyway. Okay, multi-platform only matters when you are deploying to ARM-based AWS instance. Graviton alongside x86, okay, whatever Graviton is, you want the same image to run on your Mac 4 M4 locally. We do not want the same image to run locally. Okay, that makes sense. So I guess we will be using BuildX, because in that case I would be able to pull the latest image and run it on my machine locally. That would be cool. You want the same image to run. Yes, cool. Okay. Yep, we will be using BuildX. We will be using BuildX. So, yep. So we first use Docker. What was the name? We first use Docker login action to log in to Docker from the Ubuntu latest CLI, and then we use what? Docker setup BuildX action v3 to build for multiple architectures, and then finally we use this Docker build push action at the rate v6, which builds the image for multiple architectures and pushes the image. Okay, yep. There are a few questions I need to answer, but okay. Almost small correction in step 2 is this build action doesn't build for multiple architectures itself. It just installs and configures BuildX as the active builder. Think of it as a prerequisite setup before building itself. Okay, in step 2, step 3 is where the real work happens. You specify. Okay, so step 3, we need to know about step 3. How do I, or what are the options I can give to step 3, since I am using Docker stage to define multiple images from the same Docker file, and then how do I specify multiple architectures for these images. Yep, here are the main options for Docker push action. Okay, with context, this Docker file, this is like Docker compose file, actually Docker compose. Tags platforms, we can give in platforms. Target is production. No, build arguments if you want them. if there are any target for multi-stage, which stage to build. Okay, and I guess in one build and push, we can only build one image and push only one image, and yep, and then we can build another with a different target. Okay, push, true, do push this with this tag user, and then build arguments. There are no build arguments, and we are right now looking for just backend. Cool. Labels. Cool. So target. For multi-stage Docker files. Target frontend, target backend. Yep, we use the same action again and again. Cool. Tags, we give it tag user slash this. Okay, cool. That is exactly what we need. Okay, so let's, this is steps. Okay, the next step would be, in that case, login, Docker login uses Docker slash login action version 3. And what we need for this login uses registry, GitHub, no, username and password token. Docker login username and password, Docker Hub username and Docker Hub token. We'll go to Docker Hub, or we can start Docker locally. Which is taking a bit of time to start. Sign in. These are some like test images. Settings, default, privacy. How to get Docker Hub personal access token in Docker, login to Docker home, password, account settings, personal access token. Okay. Dashboard, account settings, shared, which reroutes here. Personal access token. I will hide my screen. This might have something crazy. Which laptop you use? Mac, unfortunately. Phone is charging. Cool. I will hide my screen. Cool. Personal access token. There are multiple tokens already here. Okay. I guess I can show you this and then delete the token. Here, I guess we have to click on generate new token, and nothing happens. Expiration never. Why are there like these different tokens generated through Docker desktop? Okay, that is crazy. August 2024 is crazy. Okay, delete all of these. delete token, and delete this, delete, and delete this, and generate new token. Access permission public, read only, no, read, write, read and write, yep, only read and write. Expiration date none, and token description, hello, I like learning, no, token description is for GitHub workflows generate I guess I will delete this. You can see my token. Okay, M4. Shit. Wait. Oh shit! I deleted the my other one. My bad. I will hide my screen now. Generate new token. For GitHub workflows. Enter. Copy. Okay, I have copied it, and before showing my screen, I will add this as a secret in my GitHub. Secrets and variables, actions, new repository secret, Docker Hub token, cool, add secret and cool. Okay, now I can show you my screen. It is cool. Okay, back here. If you go to your repository where you want to add a secret, just go here, secrets and variables, then here, and add new repository secret, and you are cool. Okay, okay, okay. So now we have to log in this, which takes in with secrets.docker password. Nope, and this is not a password. Docker Hub token is the name I have used, and Docker Hub username. Docker Hub username and Docker Hub token. Login with these. Cool. And I guess my Docker Hub username is just, let's see what it is. It is my name. Cool. 127 Jitanaga 127. Okay. 137. Cool. And we just have to add this as a secret. Actions, new repository secret, Docker Hub token instead of token. CKER Hub, Docker Hub, new username, which is Jitanaga 137. Cool. Okay, we will be able to access them here. Docker Hub username and Docker Hub token. Cool. So we have logged into Docker. Now setup. Docker build X uses this. Cool. And I don't think we have to do anything else in build X. The GitHub action will do everything. And then yes, and build and push. What does this do? Build and push is the name uses Docker build and push, where context. Yep, we need to do this like multiple times. Okay, we are able to now update the image on Docker in these two steps will happen in the same step. Create and update the latest image on Docker. These two will happen in, okay, frames are dropping somehow, but fine. Docker build push action v4. Okay, here we give context, and this is like exactly how we define these things. And here build context Docker file target, build and push backend push, and target is backend, and tag backend latest, that is the name. Okay, and we need to give in any other thing. No, these things are needed when we run the actual thing. Right now we are just building. Container name, nope. Network, nope. Shit, we will create a network. Yep, we will do networking there. Image, this ports depends on, yep, nothing else is needed to be done here. Cool. This should push the latest backend image onto Docker Hub, and the image would be public, which is fine, which is totally fine. Git status, git add this. Let's see if the Docker image goes there. Git commit added, backend image goes to Docker Hub, GitHub origin main here. Yep, action is running. GitHub action. Deploy. Docker login. We are trying to log into Docker. Cool. Building, image is building. The backend image is building. This should work. This should like actually work. Exporting layers. Okay. Successfully built. The image is building. Build and push backend. Okay, there is an error. There's an error. Failed to resolve. Failed to fetch auth token. Unexpected. Wait. So there was some error. Let's see. On Docker Hub, my Docker Hub images on Docker Hub. These are the local images. Docker Scout, whatever that is. What are the images put forward by me? Hardened images. Shit, the image is not here. All content, yep. The image is not here. Okay, so which means this build step failed, and this failed because of this. Why? Tags. setup buildings, setup build. Target tags, everything was given here. Slash backend target is backend. Okay, and how to give like architectures. Platforms. Linux AMD 64, Linux ARM 64, Linux AMD 64, and Mac OS or Darwin ARM 64. Platform name, what would be the platform name? Linux. Okay, so the primary platform name used for Docker containers is Linux ARM 64. Okay, not Darwin, but Linux ARM 64. And AMD 64. Okay, but this step failed building and pushing because of this. BuildX failed with error, failed to build, failed to resolve, failed to fetch auth token unexpected status from auth.docker.login. Insufficient access token has insufficient scope. Access token has insufficient scope. Okay, what should be the scope for access token in Docker? Token for Docker Hub with workflows. BuildX personal access token depends on specific automations. The most common scope for standards here, it allows for BuildX workflow. This is the standard recommended scope, which is what we are using, but it's still hello. Yes, why? Right now what we are doing is we are writing the CI/CD pipeline so that we can push the latest image whenever there is a commit on the main branch. This thing, there is a single job, deploy, not deploy, there are multiple jobs. Push image, that would be job number 1. This thing runs on Ubuntu latest. Cool. And steps are these: check out, get the latest code, log into Docker, which we are able to do. Pretty cool. docker Docker Hub token, and then we get BuildX, which is Docker program which builds the image for multiple architectures, and I guess like you already know all this. BuildX, and cool. Then here we are getting error that the privilege of the token that we have given is not enough. BuildX failed with error. This for one authorized token access has insufficient scope. Is valid, but it does not have the scope requirement. Scopes required perform the action you are attempting. While a standard 401 usually means I don't know who you are, this variation means that the server identifies you but lacks the specific key room. Write packages. Solution: go to your provider's developer setting and find the token and ensure that the required scope is selected. It is selected. Docker Hub or hub.docker.com. hub.docker.com. Hello, what year of uni are you? I'm about to be in my 4th year right now, in me 3rd year. In a month or 2 I will be in my 4th year. And account settings, personal access token, this is the one, and source active. Okay, shit, it does have, it does not have the scope. Cool, makes sense. How do we edit? And hopefully, yes, scope. I have to change the scope to read and write. Read and write, read and write. Save token. Cool. I guess using the same token, now we will be able to do it without making any push requests. If we just rerun this job, rerun, failed job, rerun. This would work this time, hopefully. Fingers crossed. Hello. Lucky, okay. Hello. Wait, shit, the stream did not stop. I thought the stream stopped. Do you see me? I don't think you see me. Are you able to see me? Hello. The internet is now connected. Yes. Okay, okay, okay. Yes means yes. Okay, okay, cool, 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 cool. Okay, that is good. That is good. It was very, very momentary. Shit, I would have started to cry. Okay, the job was completed. Cool. We should see the image. hub.docker.com. Let's go. Backend image is right here. Let's go. Okay, but this is only built for Linux architecture. And image management tag. Yep, this is for Linux AMD 64. AMD 64 are Intel processors. Cool. So out of these, create a new image and update the image on Docker Hub. Cool. We are able to do it at least for backend. Now let's do this for frontend and go TY also. Cool. Here, step Docker login, Docker buildx. Name, build and push frontend and uses Docker action with context. Okay, when we build this, when we build the front end for production, we will do something like this. Docker file, our target would be Nginx production, not development, but Nginx production with context, this thing, target Nginx prod, I think that is the name. Yep, Nginx prod, that is the name. Nginx prod, target, container name, image, and everything else. No, we do not need anything else. Cool. Nginx prod target push is to actually push this tag secrets dot Docker Hub username slash not frontend Nginx prod latest, that is production Nginx platforms Linux, just this same line. Okay, that will build the front end and also set up the Nginx. Okay, now last but not the least, like I guess this, which is going to be the actual selling point of this, build and push TY. go ty. This also uses Docker push actions with context. Is this push true? Target is going to be ty secret. That is not the right secret. Wait, shit. I guess yes. If we change this thing to Nginx broad, that is pretty good. Attack. Okay. And for ty build, I guess we have to give something in the build. Args. Yes, in the build we have to give this argument. Localhost. We have to give an argument which we will save in which we will save as a secret on GitHub. Actions, new repository, backend API URL, and it would be the backend .walrus.codes. This should match sha.backend.walrus.codes. Okay, cool. It is sha backend walrus.codes. Okay, add secret. Cool. Now here, how do we give argument? Give arguments to Docker action build and push. Build arguments. Build args. Okay. App version this. Okay. Build args with this. We just need to pass in one argument, backend URL. Whose value? Wait, that is how we say the value is. Whose value is secrets backend URL. That would be, I guess we should change the name, not the value, the name. I guess we have to delete this. There's no, I will have to use my phone, or I can delete this later. I can delete this later. Backend URL. This would be sha backend.walrus.codes. Backend URL backend URL backend URL underscore. Okay, we will get it here. Cool. And do we need any other arguments building anything? I don't think so. This at least should be pushing 3 images onto Docker Hub, one for backend, one for Nginx production version, and one for the TUI. And yes, for backend we do not need to specify. There is no difference between the development version of backend image, not the container but the image, and there is no difference. Well, we are choosing the Nginx production version, so yep, we are choosing the right image. And for TUI, there is the only difference between the production and the development is the backend URL which we are giving here in the build image. Status, git add, git commit message, builds image for all apps. Reason main, cool, actions, builds image for all the apps. Cool. Set up Docker buildx. Docker buildx is setting up. Okay. That is building image for the backend and pushing the latest image. Pretty cool. Okay, pushing layers. This is for the backend. Okay, shit, that is, we got error. Insufficient scope. Post sec. We got insufficient scope for building the front end. There is a typo. Shit, very bad typo. Here we are defining this as front end production, PROD production, and when we are building the production of Nginx, we are here saying PROG. Shit, that was stupid. Typo in Docker file. Push origin main. It should be cool now. Fixing typo in Docker file. This is running. This is building image for backend, and also this is a server which is given to us by GitHub, which is running this service for us, and there are fixed amount of time that GitHub provides us this service for free. So free GitHub workflow time limit. GitHub workflow time limits are for free accounts are divided into two main categories: the monthly allowance for private repositories and execution time per job or per workflow. Monthly allowance, private repositories for private. Ours is public, anyone can see it. This is building the front end. This is building the front end image. Build and push front end. Right now, transforming. It is transforming something. 360 minutes. Okay, job execution timeline for each individual job in a workflow can run for a maximum of 6 hours. Okay, this is certainly not going to take up 6 hours, hopefully. Currency limits for free plans. Concurrent jobs, you can run up to 20 jobs across all the repositories. Okay, that is crazy. There essentially doesn't seem to be a limit. Set up GitHub workflow, which okay, we have made progress, which builds and pushes Docker image which builds and pushes Docker images. Does GitHub keep providing this service for forever, or is there a limit? Okay, what is this? EY is building now. Okay, which means we were able to build and push the front end successfully. This is pretty cool. With the backend URL, go build with the current back. It depends on whether your repository is public or private and the rules. If your repository is public, GitHub Action usage is free for standard GitHub hosted runners in the public repository GitHub. This has been the case for a long time and there is no indication it is changing. Okay, runner usage in public repositories will remain free. That is like pretty cool shit. If your repository is private, each GitHub account receives a quota of free minutes. Okay, ours is public, we don't have to care. Public is pretty cool. This is now building, and after building this will push the latest image onto GitHub, onto Docker, which is pretty cool. But since we have already pushed, let's go. We already have the backend image and Nginx, which is serving the front end image. And also if we go here, we should be able to see inside tags the architectures for which this is valid. This is valid for Linux AMD architecture and also ARM architecture, which is the Apple architecture. So if I were to clone this backend locally, this should run. So docker pull Github 137/backend. We'll just see. Shit. Daemon is not. Wait, what? Incorrect username. How do we pull an image from Docker Hub? A public image. Docker pull image name. Latest. Shit. Wait, or is this image private? If the image is private, okay, this is taking quite long. Building. No, this should. If this should build the thing, the Ubuntu latest machine on which this is running, it does not need Go to be there. And shit, why is it taking this long? Okay, because it is building for both the architectures. It built the Go backend for AMD architecture in 20 seconds, but it is taking significantly longer to build it for ARM architecture. Seems like stuck. It has already spent 3 minutes. And also, are these images private? No, these are public images. So okay, the name was, spelling was wrong. There was typo JATINRAGHAV/137 backend. Okay, J docker pull DOCKER PULL JATINRAGHAV137 backend latest. Okay, there is some error. Cool, we have pushed everything successfully. The Go image is also there, but why are we not able to pull this image? Should make sense, I guess, because account settings, because we logged out. Yes, because we deleted the key, and we have to log in to this Docker again. Key, it is because of the key. Wait, why is Docker not turning off? Okay, Docker, and we will log in again to Docker, and then we will be able to pull the image. Sign in. Give up. Wait, using Google. It's working. True pink shade. Okay, cool. And now hopefully if we do Docker pulling, that is good. Okay, this is downloading the image. Okay, cool. And we will be able to run this image. Cool. So we are able to successfully push out the images. Now we just have to pull the images in the AWS instance and run them, which is cool. Okay, now actions for SSH. Using Appleboy. Yep, Appleboy. Master with host name, user name, key name, and port. Private key. Okay, I have to give my private key. Okay, cool. Makes sense. Which means now, okay, there is my main public private key pair in SSH. Here, this one ID RSA, this is the main default one. I guess I should create another one for AWS specifically, which we do by SSH keygen, I think. Yep, that is the thing. Man, SSH keygen f. How do we give in the like format? File name. Such keygen of this type, store it inside /users walrus dot sh /AWS /AWS. No password. Now I need to take the private key in this and put it here, put it as a GitHub secret. And second, in the Terraform, we have to create a new key in Terraform. aws.pub. You can see this, like no problem with you seeing this. cd Terraform. We have to define a new key here. Resource AWS key pair, and name is AWS key where public key equals this. Cool. And key name is AWS key. Cool. And in instances we will give key name, but just one key name. Can this thing be a list? Terraform AWS provider. Can this thing be a list instead of a single key? In EC2 instance, AWS instance, key, we are looking for key name, optional name. Okay, but can we give a list keys? Default tag. No, there is no way. How do you key name and Terraform AWS EC2 instance? Key name this. Only one key is allowed here, and user data, cloud config. We can manually add more keys. We can manually add more keys, I guess. In that case, we will only use this key. Cool. Terraform, destroy everything. Yes. Okay, everything is destroyed. Terraform, apply. Cool. That will create an instance. Yes. And this is the public IP address of that instance that we just created. Okay, we have an instance running. We have all the images ready. We just have to put them together. Push the images. Workflows cd YAML. Okay. Jobs. Job number 1 was push images, and now job number 2 is what? Push images. Job number 2 is pull and run. Property pull and run is not allowed to needs runs on. Wait. Runs on is needed. Runs on Ubuntu latest. We will SSH using this. Okay. for SSH, how do we SSH? Using this apple boy thing. Name. Okay, yes, steps. No, we are not going to do any this. Name is SSH. Uses appleboy actions with hostname SSH host. Okay. Username would be Ubuntu key SSH key. Okay, we will give it, and then the script to run there. And I am getting a call from the system. Git pull? No, there is no git pull. Cool. So host name we have to provide. Put 3 new GitHub secrets. One is SSH host, SSH username, and SSH key. Secrets and variables, actions, SSH key. Wait, in a minute. Host, SSH host. Yep, we have to give an SSH host, which is walrus.codes. But can SSH host take in a domain name, a DNS name? Apple boy SSH take in a domain name as SSH host. Yes, so it can take in a domain name, in which case walrus.codes is fine as the SSH host. Then SSH user, SSH username. Username, which is Ubuntu, and the SSH key, for which I will have to hide my screen. But before hiding, pb copy. Yes, pb copy is the command. So cat /.sh /AWS copy this or pipeline this to cb copy. That copies the secret key in the clipboard, and I just have to go to GitHub, create new key, SSH key. If it is not already defined, it is already defined. Edit SSH key, just paste here and update secret. Cool. So let me hide the screen. That was shit. I have to use my phone to verify. Okay, I will have to use my phone. Wait a minute, let me also hide my camera along with the screen. You can see the screen. You can wait. Shit, why this? Wait, don't tell me this thing has been there since yesterday. Cool. Okay, let me hide my camera. GitHub. And shit, I forgot. I guess the code was 76. Cool, wait, I have to hide my screen also, just to make sure everything worked fine. Everything did work fine. Okay, cool. Let me show you my screen back. Cool. Pretty good. Okay, so we have everything: SSH host, key, and username. target 0. Okay, this should be able using this. Okay, and we also have to give in the port is share. I guess we should also add the port as a secret just to be professional. SH port 4021. Well, not very professional to show it on the stream, but very professional port, and everything is cool. Secrets.ssh path cd into the ssh part. No, do not this. We will see if this is able to go into the machine and do touch hello.txt. This GitHub workflow file.txt. If we see this file inside our remote server, that means everything is okay. Cool. SH into remote SH and script. Okay. Git push origin main. Let's see actions. SSH and run a script. If this thing runs, that would be pretty cool. Okay, shit. These two jobs are not independent. Makes sense. These two jobs are not independent. This will take pretty long time to run, and this would just run immediately. Touch GitHub workflow file.txt. Error. Why error? Sync false, debug false. What is the problem? Touch workflow file script with all this host name, username, port. Wait, why is there an error in SSH? Debug false, script is stop false, cipher. SH Appleboy action. Script, who am I, and all this. I guess the version that we took was not cool, uncool. No, the version is cool. Wait, it might be higher. Wait, this is like version 0. Okay, we took the wrong version. Appleboy is action. Cool. What is the latest version? These are things: parameters, host, port name, username, password, protocol, and what is the current version of this thing. Master, I guess we can say. Okay, version is 1.2, 1.2.5. We messed up totally in the version, and we used this does not even exist, 1.2.5. Or I guess we can even give in the name of a branch, master. It fix origin main pull. Okay, the last one hasn't even completed, and we made another request. Fix CI/CD. This will also shit. Okay, that is a lot of work for a single thing to do. Entry point.sh. Cool. I guess now it will work. Now it will work. Hopefully. Drone SH version this. One 1.8.2 is the latest. That is released. Which line specifically gave us error? Port 44. Port is 4321. And shit, of course, this is not working because the name walrus.codes doesn't correspond to the correct IP address. Login with GitHub, Google. 8 p.m. already. Let's finish this up. Manage DNS records. Output. This is change, edit, update, SHA backend, update walrus.codes. Update this and edit this. Cool. DNS dnschecker.org walrus codes. It is already everywhere. Cool. And now the action should work. Cancel workflow? No, wait. Rerun failed jobs. But I guess we cannot rerun until a job is running. And that is taking very long. Building the Go backend. I'm getting full. Wait. ARM 64. I guess I can just exclude this for Go specifically because this is taking quite long. This is actually taking quite long. In which case, we don't have to give platforms. Wait a minute. I guess I'll be right back in 1 minute. Hello. I'll be right back in one minute. I'm getting a call. I have to tell in my house. Tell someone else to call. Wait, let me hide my screen. Hide my face and my voice. Cool, and I'm back. Pretty cool. And okay, this image was pushed. Actions. Okay, this building the Go image is very slow. I guess just because of the platform, somehow building the Go image is very slow. So I have changed the settings for building the Go image. Okay, wait, this was not even building the Go image. This was taking time in building the front end image. Shit. Wait. Yep, it was taking time to build the whole image. My bad. Now this one. This job failed, which is bad. Rerun this job. Rerun jobs. Wait, do not rerun both the jobs. Just rerun this one. Pull and run. SSH, in which we are SSHing into the remote server. And yep, hello. Shit, that was quick. Okay, we were able to SSH into the server, and in the server, remote server, if we were able to SSH, we should see this file, GitHub workflow file. Okay, let's SSH manually. SSH as Ubuntu into Walrus. Wait, we have to give in the private key, which you do not have. I do have. .sh / AWS. Yes, that is the key. And username Ubuntu @walrus.codes. Enter. Shit. Port is 4321 for SSH. Yes. Okay, we are in, and we do see this file, GitHub workflow file.txt. Okay, that is pretty cool. So the only step, there is just one step remaining in this whole thing. We are able to SSH into the remote machine. We now just have to, we also have Docker on the remote machine. We have all the configuration we need on that remote machine. We just have to set up Docker, pull the latest image using Docker pull, and run. But I guess we also have to log in. Can we pull Docker image without login? Can we pull Docker image without login? Yes, you can pull a Docker image. Okay, we can test. We can test. Not this. SSH with the secret key being .sh / AWS Ubuntu Walrus.codes. That is the domain name, and port is 4321. Okay, and here if we do Docker pull JTIN 137 / backend. Does it work? No, it does not work, because the Docker server is not running. How do we start the Docker server? System ctl status Docker terminal enabled and running. Docker pull 137 / backend. Permission denied. Okay. Either the Docker engine is not running, and the Docker engine is running. Permission denied. Sudo Docker build this. Okay, Docker engine is running. Sudo Docker pull 137 / backend. Okay, let's go. That does work. Okay. Sudo Docker pull. We will pull. We already have the image for all the things. We will pull image for TUI, for the front end and the back end. Make a connection, make a network, and then run them. Cool. Exit. You must attach. Cool. Let's define a script which does all this. Scripts deploy this, create a new script, docker.sh shebang mash sudo docker pull /137 slash backend latest sudo docker pull GATINRAGHAV 137 Nginx prod production 137 and sudo docker pull GATINRAGHAV 137 slash UI latest. Okay, this will get the images. Sudo docker network create sha create this network. Now is the thing. Okay, to run backend, building is totally cool. To run backend, how to create docker network only if it doesn't already exist. Okay, can you summarize, give a summary of what you've done? Okay, so it took me about 2 months to build this app where I built the backend, the front end, and also a TUI through which you can play chess. It has everything written by scratch. That is for validating if a move is correct or not. All the logic was written on these streams by hand, and then when you have an app, you have to deploy it. So this whole month, 18 days, this has been about deploying the thing, in which we saw what is Docker, how to work with Docker. We have gone through Docker and some sidetrack things, and then yesterday Docker Compose, then Terraform, and now, and also we did CI/CD stuff, and now we are actually putting everything together to make this thing actually work. We also did AWS, how to deliver it. Okay. I guess you just have to know that if you do not work hard, or if you are delaying the work right now, what makes you think so that you will not delay your work later on, right? And yep, like just like just do not make excuse, do the thing. One liner. Docker network inspect. Docker network inspect dev null. What does this do? Dev null, and then and one do. What does this do? Yo, hello. Okay, the command this is used in a Unix like file system, also in Mac OS, where this redirects the standard output to a specified file called dev null. Okay, okay. Standard output goes there, represented by the number 1, which is here a command that sends successful. Okay, dev null acts like a black hole. Okay, so output goes to dev null. Then this redirects standard error to the standard output. If there was an error, this redirects standard error to wherever standard output is currently going, which also is dev null. Standard error represented by number 2, where a command sends error or diagnostics. The and is crucial. It tells the shell that 1 is a file descriptor, a pointer to the output stream rather than a literal. Since standard out is already pointed to dev null in the previous step, standard error is now also sent to the black hole. So everything goes to the black hole. Correct? Is this prints standard out. If there is an error, if there is no error, then this thing just goes there. And what is this part? Okay, shit, what is this? Hello. The logical OR separator. Okay, the primary function of this is to execute a command only if the preceding command fails. Okay, cool. Shit, that is pretty cool. Okay, okay, okay. Script: create network, docker, inspect network, SHA, that is the command, docker inspect, docker network inspect makes sense, docker network inspect, I guess this is it. This is it. Okay, this will create the network, get the latest images, get or create network if it doesn't exist. Create the network. Okay, cool. Backend container. Okay, I guess we can just start the container. First of all, we have to start the Postgres container. Wait, Postgres, there is no Postgres container. We cannot just put our password for the database out there for anyone to see. We have to give an environment variable when to start the container. Docker run in detached mode. Name backend port 2222. Environment variable is this, something like this. Database URL whose value, I guess we use equal to here. We have to change this to the actual backend connection string, and I guess we can do like this. Secrets dot database URL, and we can store this in the GitHub secrets. We have given this ports, and we have also given in the name network we have to attach. Network is star, and the image is within Argo 137 backend. Okay, that should start the backend. That should hopefully start the backend. And let's store into GitHub actions or GitHub secrets the correct image. The man is speaking. The correct key secret. AVN database. This is the database that we are using for this. Database. Yes. We have to do something about the fact that if an error happens, if the backend throws an error, then the server will go down. How do we fix that? When running backend on Docker in AWS, if the backend throws an error, how do I make sure that it restarts? How do I make sure that it restarts? Automatic restart and failure on Docker in AWS. Docker Compose. I'm not using Docker Compose. Plain Docker run. Oh shit, we can just restart. On failure limit. Failure limit. Nope. On failure 5, what does on failure 5 mean? Is it like a limit? The 5 is maximum retry. Okay, 10. How's that? How's that? Okay, that should do it. Restart. Database URL, but also we changed the backend to not SSH into the chess database inside the database, but instead access the tables in the global scope and not inside a specific database, which means we have to quick connection. I will hide my screen and wait. We have to do two things. PSQL help okay. I will hide my screen in 1 minute. Quick connection. PSQL copy. Cool, that works completely. Cool. You can now see the screen here. Backend database and it dot. Wait, there was a place where in Docker Compose, Yep, we'll get this. Cool, all the tables are. If I click exit, maybe. Okay, cool. You didn't see the actual thing. Okay, cool. You didn't see the password. Compose init.sql, init.sql. Cool. Okay, volumes. Yes, cool. And paste the same URL here. You do not see the password, which is pretty cool. Let me hide my screen again. Cool. Okay. The secret is also here. Now, database URL, which we will be using here. Secrets database URL. Will this work? Let's see. Will this be able? This is inside a script.sh file. Will this be able to get the secret from GitHub? Secrets, will it? 8:30. Bro's thinking. For real, for real. We can close this, close this. No, it won't. Shit, shell scripts do not have access to GitHub secrets. Okay, okay. Option 1 pass this as an environment variable. Which makes sense. We can do this. We can do this. Okay, we will pass this as an wait, shit, no, database URL, database URL. Boy sh. How do we give it a script? Ah, shit. Boy SSH action. Script path. Scripts. environment variable. This is going to be list probably. Database URL has the value secrets dot database URL. Incorrect type expected string. Oh shit, makes sense. Key value pair and not a list. That should start the backend. Now backend with the correct Postgres URL. Shit, that is messed up. Name Nginx prod start on failure 10 times, port 80. Okay, this should like actually work. And what do we have to give in when we are running Nginx? When we are with this is not the right place to be looking. Here, container name, image, port 80 depends on backend. Cool. Port, we have already given the port. Network, no network is needed here. Just the name 137/nginx prod. Cool. And now the last thing, docker run in detached mode, name ty, restart on failure 10 times, port 22 to port 22. Backend URL is something that we will give here, but port mappings 22. Okay, depends on backend. Fine. This needs network and e backend URL equals backend URL TUI, and we have to give the backend URL secrets backend URL here. Okay, that should work. That should actually work. We'll see. Hello, yo. Yo, hard at work. I see. Trying to. And sorry, why? My bad. We will meet. As soon as I'm done. We will do our secret thing. Okay, this should work. Fingers crossed. Let's reread this because it would be very cool if this works in one try. We do know for a fact that everything in this file is working fine. We are able to access it. The only thing that I'm not sure about is this script path. This might break us. That would be fine. Okay, that is the only point of failure, script path in this file. And then in scripts, I don't think these would cause any error. Docker create network, only create this network if it does not already exist, and this would fail if we do not give. Okay, and here run container in detached mode. Name of the container is backend restart if it fails at max 10 times. port 222. We don't actually need port mapping. We do not want our backend to be accessible like this. Yep. We do not need port mapping here. Fine, cool. Okay. And the backend needs an environment variable, which is the database URL. Pretty cool, pretty cool. And this is accessible here because we are defining this. And here, before calling this script, here we are defining the backend URL and the database URL. Database URL should be accessible here. Then we add this container to a network called SHA, and then comes the name of the container, Jatin Raga 137 backend. That should work. Okay. And then start another container. Detached mode. Name is Nginx production. Restart on failure 10 times, same as above. Port 80. Port 80 of this container should be matching to port 80 of the actual machine, the host machine. And the name is Nginx production. For this Docker run in detached mode, name TUI, restart 10 times failure, capacity port 22, this is the TUI network SHA. Okay, this might actually work. And also on the AWS side, port 80 is accessible from anywhere on the internet. The security group is fine there. Okay, what are the changes here? I guess we removed the extra line at the end. Git. What? Oh, we added sudo. Yes, cool. Git. Okay. If this works, that would be very cool. Actions. This. Shit. Typo. There is a typo. Okay, shit. There is a single typo. Shit. Not at a single place. All the places. SECRET. Wait. SECR. Okay. And anything else? Shit. These two things. Oh. Bro gave up. Why? No such file or directory, because makes sense. We have to do git checkout. We are only doing git checkout on this one. We also have to do git checkout here. Wait, was that correct? Git checkout. Good, that's a good. Okay, new one is running. New CI/CD is running. Okay, we haven't exited. Script is running. Pulling layer. Download completed for something. Okay. Okay, wait, are we stuck or something? Nginx is downloading. Okay, okay, we are slowly pulling the images on the AWS backend. Oh, shit. There is one error. Process completed with exit code 1. Docker run help. Shit. But container network SHA not found. Which I guess shit, Google messed us up. Will this only create a network if one doesn't already exist the given name? No shit, Docker requires a network. Okay. And anything else? The correct way? We have to give in Shire. Pulling. This is pulling the images, the latest ones. 8:45. And wait, how long has it been? 2 hours 18 minutes. That is fine, totally. Okay, shit, there was an error again. Permission denied. Shit, sudo. That will that this hopefully, like I'm pretty certain that this would work. This would work. And while this is testing, let's do one type tracer. This is like smoke addiction. Okay. These brave men, Neil Armstrong. Okay, almost good. Wait, shade error. Backend is already running. So what is a Docker command? To stop a container if it is running with a given name, and then remove the container if it is running with a given name. Stop existing containers. Sudo docker rm. Think we can give force here. If the containers are working, then stop them and remove them. Docker start or run in background py. Docker remove force c0b. Cool, that works. Docker remove force backend Nginx production and ty. That should work. That should work. And hello, 3 people. Wait, what is this? Delay ads, insert. Okay, let me show you a ad. Wait, did you see a ad when I clicked on this? Ad inserted. Did you see a ad right now? Or maybe if someone was watching a video, they would see a ad. Someone is watching this stream afterwards as a video, they would see a ad right at this moment. That is cool technology. Delay ads. That will do something, I guess. Share, do not put any ads within 10 minutes of this, I guess. It. Okay. All. Yeah, that is something that we have to fix. The images were not pushed, but they were pulled. Yeah. And which means we just got the older images. I have defined multiple jobs in GitHub workflow. How do I multiple jobs in GitHub workflow? Make one run only after another has finished running. Something like this. Needs. Okay. Job needs build. Okay. This whole thing worked. This needs this job push images. Okay, and now this one depends on this. Cool. Cool. Very cool. And when this finishes, I would end the stream because it has been long enough. Cool. That is very cool. But okay, look at this. sh walrus dot codes. sh first try walrus dot codes. Let's go. It is working. There are some bugs, but let's go. It is working. If I go to walrus dot codes, let's go. Cool. And let's see. Walrus 1234 with a certain password, and we see this as red because like this. Dark mode would be cool. Error while creating account. Least connection refused. Okay. Course. Wait, why localhost? Why is, yeah, there are some bugs which we will fix slowly, but cool. We are able to deploy this thing. It's pretty cool. Annotations. Why? Node.js 20. Follow the instructions. Use something better than Node.js. Okay, that would be it for today. Or like actually today, I won't be streaming anymore today. Cool. We are able to pull the images. We are able to restart the Docker container. Now we just have to fix some bugs. And that would be it for today. Thank you for being here. Bye.